So what I want to talk about now in this video is talk about sigma versus pi bonds. Again, this is going to be, again, overlap of orbitals, and this is going to determine if the bond is going to be a single bond, double bond, triple bond, etc. Again, it's overlap of orbitals in certain directions that determine now if it's single, um, if it's a sigma bond, pi bond, single bond, double bond, triple bond, etc. The first scenario is we're going to look at sigma, a sigma bond. Let me use that Greek symbol, sigma, and the definition is overlap along internuclear axes. Again, it's overlap in between two nuclei. So for instance now, say I have this. And this is for the two different carbons. This is carbon 1 and carbon 2. They're going to overlap along these directions right here. So when you have the orange and a pink balloon overlapping, that's a sigma bond. They're going to overlap in between. I'm going to show you how it's going to be compared to a pi bond in a second. Sorry, but basically, if you have a single bond, it consists of one sigma bond. Again, that's going to be important. Sigma is along the axis, so along. Let's call this carbon number 1 and number 2. Both of these are sp3 hybridized, but these overlap right here, that shaded area. That's the sigma bond along the axis. Now we're going to compare it to a pi bond in a second. The second type is going to be a pi bond. This pi bond is above and below the internuclear axes. So basically, say I have the two carbons, and these are like two p orbitals, so they're going to kind of overlap like this. So the orange and the pink overlap on the top, and then the two pinks overlap on the bottom. And notice that the overlap is not as much. So they're overlapping. And so it's a weaker bond because it's less overlap. Pi bonds are going to be involved in double bonds. So sigma bonds are involved in single bonds. Pi bonds are going to be involved in double bonds. And again, my balloons are running away. It's just like an overlap. Like these are the two carbons. My hands are on the two carbons, and it's above and below the internuclear axis. And it's a less overlap. It's going to be a weaker bond. Now, in the second, I'm going to show you how we make up single bonds, double bonds, and triple bonds. It's an overlap of the sigma and two types of pi orbitals in different directions. So just to kind of finish this up, a single bond, is made up of one sigma bond. So whenever you have a single bond, it's made up of this overlap along the internuclear axis. Now, if you have a double bond, you have one sigma plus one pi. So you have both of those. They have to have both. You have a long internuclear axis and then two p orbitals going above and below. Triple bond, one sigma plus two pi bonds. So again, always one along the sigma, and then two. Again, these goes up and down, and the other one could be like kind of like in a y, two py orbitals kind of overlapping off on the side. So again, this is important. Sigma, single bond is one sigma. Double bond is one sigma plus one pi, and then triple bond is one sigma plus two pi bonds. Like this one right here. This is a triple bond between two carbons, a double bond, and then a single bond. So again, this one right here will have one sigma. This one, you can think about the bottom one as a sigma, and the top one as a pi, one pi. And this one right here, the bottom one as a sigma, and then this is one pi, and then this is another pi bond. So again, know the difference. Triple bond, one sigma and two pi. Double bond, one sigma plus one pi. Single bond is just one sigma bond. Now in a second, I'm going to draw another one, and we're going to look at the bond lengths. And this is really how you determine if a scientist does, if it's a single, double, or triple bond. So just to kind of finish this up, in terms of bond lengths, this is how you can determine if you're a scientist, if it's a single bond, double bond, or triple bond. You go by the bond lengths. A single bond is 154 picometers. Again, this just considers of one sigma bond only. A double bond is one sigma plus one pi. Again, it's shorter because the overlap, because not only do you have a sigma, but you have the pi bond attached to that. So both of those combined now it's going to make it a stronger bond, more difficult to break. It's just like saying breaking one pencil is easier than breaking two. When I get down to 3 pencils, the overlap's even better because I still have that sigma plus 2 more pi's that overlap. I get down to like 118 picometers, and this is the strongest. This is 1 sigma plus 2 pi bonds. So basically, triple bonds are stronger than double bonds, which are stronger than single bonds. So it takes more energy to break a triple bond. Again, remember, it's like breaking 3 pencils as opposed to 1. And I'm going to make another video in which we're actually going to look at some examples of how to determine hybridization and how to determine sigma pi bonds, etc.